So rational expressions get divided in the same way that we divide rational numbers. And one of the common expressions for this is to say we skip, flip, and multiply. So what that means is we take our second term, okay, our 7 over 2, and we flip it, okay, or skip the first term, go to the second term, flip the second term, and change it to a multiplication. Okay, skip, then flip, then multiply. And so once we change our second term over, we get 3 times 2 gives us 6, 5 times 7 gives us 35. So dividing rational expressions is very similar. To divide, we have to multiply the first expression by the reciprocal of the second. Then we have to factor all these expressions and factor out what's in common. So let's kind of use a couple of examples and see what this looks like. So the first thing that I'm going to do is I'm going to simplify this. We're going to factor them out. And again, I'd encourage you to pause the video, try it out on your own, see if you can do the factoring, see if you can figure out how to flip it, what cancels out, and what those non-permissible values are. So pause the video, give it a try, and come back when you're ready. Alright, so in our first term, it looks like I have a 3 that can be factored out, x minus 1. On the bottom, it looks like I have 2 things that multiply to make negative 6, add to make negative 1. So it looks like I'll have x minus 3 and x plus 2. And then looking at my next term, I'm going to keep my division for right now. And then we're going to take a look at factoring this. So x squared minus 6x plus 5, 2 things that multiply to make 5 and add to make negative 6, x minus 5 and x minus 1. And then on my bottom part, I have x squared minus 3x minus 10, 2 things that multiply to make negative 10, and those same 2 things we'll have to add together to make negative 3. Looks like it's going to be x minus 5 and x plus 2. Now I'm going to flip my term, okay? So I'm going to skip my first term, flip my second term. So 3x minus 1 over x minus 3 and x plus 2. I'm going to change this to a multiplication. X minus 5, x plus 2, all over x minus 5 and x minus 1. So I flip my second term. Now I'm going to go through that canceling step where I'm looking for things that I can factor out or common factor. The x minus 5s will common factor out, reduce to 1. And same thing with the x plus 2s, they look like they cancel out. And the x plus 1s also cancel out. So a lot of things reduce here. So simplifying this, I'd have a 3 on the top and an x minus 3 on the bottom. Everything else will cancel out. Now, in terms of my non-permissible values, we have to look and see with each part what gets canceled out. So I actually have to start at this step with my division and take a look at each one of these to come up with some non-permissible values. This looks like it's going to be x cannot equal 3, negative 2, 3, negative 2, 5, and negative 2. So 3, negative 2, and 5. Those are the ones that are non-permissible values. Now, in my next step, notice that we changed the division to a multiplication. So now I have 2 different values that are down here that I have to compare against. Well, we already did the 5, but we haven't done the 1 yet. So 1 is a non-permissible value as well. And then the question might be, well, why do you have to look at your non-permissible values when they're divided? Because we know we have to flip them. And the answer to that would be is that if you took, let's say, the x plus 2 here, and I identified that as a non-permissible value, so we plugged 2 in, if I got a 0 on the bottom in this expression, and then I divided my first expression by 0, I'm going to end up getting that undefined error. So what we actually need to do is we need to identify non-permissible values both when it's a division as well as when it's a multiplication. So we need to take a look at it twice. Alright, so example 5, Again, I'll get you to try this one out on your own and come back when you're ready. All right, so with this one, I have 4x squared minus 25y squared. I'm going to start with that. It's a binomial term, and every value there is a perfect square. So I really have a 2x minus 5y and a 2x plus 5y over, I can't do anything with the bottom term, 3x minus 2y, they just stay the same. Now, my division, I'm going to keep that as it is because we're going to factor first. Looks like I can take an x out on the top. I've got 2x minus 5y. And then on the bottom, we haven't actually encountered these ones very much. Do you notice that they're perfect squares on opposite ends, but it's not a binomial term? In my first expression, I'd have to do, and sorry, by first expression, I guess I mean the 4x squared minus 25y squared. There's a minus sign tucked in the middle between these binomial terms. Here, I have perfect squares on both ends, but I also have that middle term. And when that happens, you still do your difference of squares approach. So you take the perfect square of each one, but both of them share the same sign. And in this case, both of them are negative, and they'll always be negative when you come into this scenario. So in here, what I actually have, and this one might have been a hard one to factor, and that's okay, I'd have 3x minus 2y and 3x minus 2y. And if you were to FOIL this out, what you'll see is that you'll get that denominator back again, right? 3x times 3x is 9x squared. 3x times 2y is minus 6xy, and then minus 6 more xy off the inside terms. So that gives you your 12xy. And then your last two terms, minus 2y and minus 2y, give me positive 4y squared. So just a little factoring trick as we go through this. Now my next step is to do the skip and the flip. So I'm going to rewrite out my first part. I've got my 2x minus 5y and 2x plus 5y all over 3x minus 2y. And then I'm going to flip this to a multiplication, so I'm going to have to rewrite out 3x minus 2y and 3x minus 2y. Yes, those I could just rewrite that once and put a squared term on the top, but I like to keep them separate in case things start to cancel. And then on the bottom, I've got an x and a 2x minus 5y. So now I'm going to take a look and see what cancels out. Okay, what can factor out to make 1. So 3x minus 2y divided by 3x minus 2y, that's 1. And 2x minus 5y and 2x minus 5y, that's 1. And then I can look and see what I have left. So it doesn't look like anything else cancels, so I have 2x plus 5y multiplied by 3x minus 2y all over x. Then I could take a look and see what my non-permissible values are for this. So the non-permissible values, they might take an extra second to go through here because of all of the different things that we have. So let's start at the division step and identify some non-permissible values. Do you see how I have two of them that are the same? I have 3x minus 2y twice. So what we're saying out of this is 3x minus 2y cannot equal 0. That means that 3x cannot equal 2y, which really just means that x cannot equal 2y divided by 3. So there's my first one. X cannot equal 2y over 3. Now, what about my next one? Actually, I've got 3x minus 2y on all three of these. I guess I didn't notice the third one. So that's it for that step. It's all the same term. Now, when I flip them, now I've got an x term and a 2x minus 5y. So those are new. Well, I know x here, right? X can't be 0. So 0 is 1. And then I have this other one, 2x minus 5y. So 2x minus 5y cannot equal 0. 2x cannot equal 5y, which means that x cannot equal 5y over 2. So x cannot equal 5y over 2 as my other restriction. So I have my simplified version, and I have all my non-permissible values. So there are a couple of questions for you to try for the next assignment, and let me know if you have any questions, and good luck.